Hey, everybody. This is Homer Simpson, and this lesson will be on matrices. But first, let's do board problem number 9. Okay, let's just solve this system. We just did this, you guys. So I like to, there's other ways to do this. There's a way called Cramer's rule. I'm not a big fan of Cramer's rule, especially when it's a 3 by 3 matrice. I think it gets harder. It does for me. So I like to do this. I like to first label the equations 1, 2, and 3. And then if you scan over these x's, and I don't want to fool with these x's because they're all different numbers, but because this is a 1y, I can change this to a 2y, and I can change it again to a negative 3y, and I can cancel it out. And so what I did was I took equation number 3 and I multiplied it times 2, and then I'm going to add it with equation number 1 right here. Okay, so this times 2 is 14x, times 2 is 6y. I'm sorry, this one times 2, sorry. 6x and then plus 2y plus 12z equals 14. Okay, and then I just slid equation number 1 down below it. Now I can add them together, and what happens is the y's cancel out. Okay, now what I want to do is get rid of y's with equation 1 and equation 2, I'm sorry, equation 3 and equation 2 this time. All right, so I'm going to now take equation 3 and multiply it by negative 3. That way it'll cancel out with this positive 3. I want to make sure to get rid of the same variable. So here we go. And then so I call these equations 4 and 5, and now I'm just going to solve equations 4 and 5. So I put those over here, and I multiplied this equation times 2, gives me this one right here, and then I can add that, and these 16 z's will cancel out, and then I get x to be 1/2. That's okay. Fractions are cool, you guys. Don't let fractions scare you. Okay, I put x back up in there, and I get z to be 3/4. And then I took equation number 3, because equation number 3 just had that 1y by itself, so I'm going to plug in 1/2 for x and 3/4 for z. Okay, that's what that is right there. 3 times 1/2 is 3/2. And then I'm going to cancel. This 2 goes into 4 twice, 2 goes into 6 3 times. So I'm left with 9/2 right there. So 3/2 plus 9/2 is 12/2, or 6. And you get y equals 1. So your final answer is 1/2, comma 1, comma 3/4, x, y, z. Always alphabetical order when you list ordered pairs. Okay, so a matrix is a rectangular array of terms. So here's an example of a 2 by 2 matrix. Here's an example of a 2 by 5 matrix. 2 rows. Rows are the horizontalies. And then the columns, think of a column that holds up a coliseum. The columns are the pillars that are holding it up. They go up and down. So these are columns here. So it has 5 columns, has 2 rows right here. Alrighty, there's a 3 by 1 matrix. Okay, okay. So here I have two 2 by 2. Or I'm sorry, 2 by 1 matrices right here, and if they're equal to each other, then this row equals this row, and this row equals this row. So that's what I have over here. And now we're back into what we've been doing a couple of days ago. I'm going to go ahead and substitute this 4x in for this y right here, and then solve for x. Okay, I get x equals 2, and then when I plug in x equals 2 into right here, I get y equals 8 right there. Alrighty, easy enough. Okay, so let's see, use the matrix, these matrices right here to find each. Okay, so we have 3 matrices, a 3 by 3, a 2 by 2, and a 2 by 3. Okay, so let's find 4 times c. So that's easy enough. You just multiply all of these elements in here times 4. Piece of cake. It's almost so easy, it's embarrassing, right? Okay, how about a plus b? Okay, a plus b, I would need to have the same amount of columns here equaling the same amount of rows here to add them. And I can't do that because I'd have to add 4 plus 4, and then the middle one plus the, well, there's no middle one here, so this one's not possible. I can't add those. All right, a times b. Okay, you're going to find this one's not possible either because I need to have these columns, the number of columns match up with the number of rows. Here I have 3 columns, here I only have 2 rows. So that one's not possible either, you guys, because you have to have the number of columns in the first one has to be the same as the number of rows in the second one. All right, well, how about b times c, you guys? Okay, let's see. I have 2 columns, and I have 2 rows over here, 1 row, 2 rows. So I can do this, you guys. So I'm going to do that on this page over here. I have 2 columns in the first one and 2 rows in the second one, you guys. Remember, the columns are the up and downs, like a column in a coliseum. They hold up the pillars. Okay, the rows are the horizontalies right there. Okay, so what I'm going to do is do 4 times this 1, okay, and then I'm going to go 2 times this 2, and I'm going to add it together, and then, I'm sorry, so 4 times 1, 2 times 3, okay, and then I'm going to go for the middle number, the middle top number is going to be, you'll see in just a second, 4 times 2, 2 times 1, okay, and for the top right number is going to be 4 times negative 3, and then 2 times 0, and you add them together, okay, look, I have it all explained right here, okay, so here I did 4 times 1 plus 2 times 3, okay, and then for the middle one right here, this guy right here, I do 4 times 2 plus 2 times 1, and then for this guy over here, it's going to be 4 times negative 3 plus 2 times 0. And then for this bottom row right here, I take this bottom number, 2 times negative 2 times 1 plus 3 times 3. And then for the middle bottom, I go negative 2 times 2, 3 times 1 right there. And that's how I get that right there. And then you just simplify that stuff up, and there you go. Okay, easy enough. All right, and if you're in my pre-calculus class, that's what I would assign you guys.